So we're starting this problem here. Change f of x to its vertex form and use that to answer the questions and sketch the graph. So we want to change this to vertex form. So I put up here what was on the previous page to give us the steps for changing general form to vertex form. Notice how we need to factor out a. A is not 1, so we must factor that out. And up here we have b divided by a. That's what happens when you factor this number out of this term. So even though it's not a like term, you must always factor out a. Let me show you what that looks like. So we factor out a -3, keeping the constant on the outside. So if you factor a -3 out of a -3x squared, you're left with an x squared. If you factor a -3 out of a -4x, you're left with a positive 4/3 x. You can double check that by multiplying it back out. -3 times x squared is -3x squared. -3 times 4/3, the 3's would cancel, leaving you with a -4x. So you can multiply it back out just to make sure you did all your math correctly. That's what's different between the last problem we did and this one. So now what we need to do is take half of b and square it. So half of b squared. So we have 1 times 4 is 4. 2 times 3 is 6 squared. Well, that's 2/3 squared. That'll make my numbers a little bit easier to work with. So we end up with 4/9. Add this inside your function. But the question is, did I really add 4/9 here? If I were to multiply all this out and clean it up, I should get what I started with. I did not just add 4/9. I added -3 times 4/9. -3 times 4/9 is the same thing as -12/9 or -4/3. That's really what I added in there. So if I added a -4/3, I have to, that's like subtracting 4/3, right? I need to add 4/3 on the outside to keep it all balanced. Now that one's a little bit confusing, so go back and play it again if you need to, go through those steps one more time. There is nothing wrong with that. So if we factor this, remember what we said before, the shortcut is, it's whatever you got when you took half of the middle term or the square root of this one. So our function becomes -3 times, we have our x, we have our plus, this one here, the square root of that one is 2/3, and it's all squared, plus, if you do 4 plus 4/3, 4 is the same thing as 12/3, right? 4 and 12/3. 4/3 plus 12/3 is 16/3. We have now written this in vertex form. So the next question is, does the parabola open up or down? Looking at your a in the function, a is negative, which means it opens down. And the question is, what is the vertex? Well, we can get the vertex just by looking here. The vertex is going to be -2/3, 16/3. So if we wanted to graph that, -2/3 is somewhere in here. 16/3 is what, 5 1/3? So 1, 2, 3, 4, 5 and a little bit. So it's about there, and it's opening down. We need our axis of symmetry, which is x equals the x coordinate of the vertex. So that would be x equals negative 2/3. We need our y-intercept. Sometimes it's easier to go back to the original function rather than going back to the vertex form. Look at this one. If we go back here and let all of our x's be 0, don't we just get 4? I'll write that out. So we have f of x is equal to negative 3 times 0 squared minus 4 times 0 plus 4. That's 0 and that's 0. We just get 4. So our y-intercept is the point 0, 4. 1, 2, 3, 4. Now we need our x-intercepts. That's where you let y equal 0. So we have 0 equals negative 3x squared minus 4x plus 4. Now we could try to factor this one. I don't know if it will, but we can try. Or we can use the quadratic formula. Sometimes it's easier just to jump in and use the quadratic formula. Then negative b plus or minus the square root of b squared minus 4ac all over 2a. Let me just double check that. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Alright, so we have 4, and that's what, 16. Negative times negative is positive. 4 times 3 is 12. 12 times 4 is 48. All over negative 6. So we have 4 plus or minus the square root of 16 plus 48 is going to be 64 over negative 6. How about that? It would have factored. So we have 4 plus or minus 8 over negative 6. 4 plus 8 is 12. And 4 minus 8 is negative 4. Make sure I did all that correctly. 12 over negative 6 is negative 2. And negative 4 over negative 6 is 2/3. So your two x-intercepts are negative 2 and 2/3. Negative 2 and positive 2/3. Now we have all of this information. Let's sketch our graph. So our vertex was here. Our domain is everything. And the range starts at negative infinity, stops at the vertex. So it stops at 16/3. So this particular problem asked us one more question. Is there a maximum or minimum value? If so, where is it and where does it occur? So you can see looking at this graph that the parabola opens down. Since the parabola is opening down, we do have a topmost point. That means we have a maximum. If our parabola opened up, like this one did, see how this parabola opens up? We would have a lowermost point. So we would have a minimum in this case. So here we do have a maximum. That maximum is whatever the y value is. The y value is 16/3, right? So the maximum value is y equals 16/3, and it occurs at x equals -2/3. That's how you would answer that question. Didn't realize I was off the screen. Sorry about that. So the maximum value is y equals 16/3, and it happens at x equals -2/3.